Going to talk about Young's double slit experiment. So it showed that light had to act like a wave. It doesn't just act like a particle. Because if you had two slits and shine some light onto them, you would expect to see two bright lines on the screen. And here we're going to show you see something very different than just two bright lines on the screen. So here's our experiment. We have green laser pointers hitting this slide. And on the slide are a pair of slits, pair on the top and a pair on the bottom. The pair on each of those slits in width, the slits are 0.04 millimeters wide, both on the top and the bottom for each of the slits. But the spacing between the slits is different. On the bottom we have a smaller spacing, 0.125 millimeters. And on the top, the spacing between the two slits is 4 times bigger than the bottom. So it's 0.5 millimeters on the top slit. So as you can see, when we project the pattern on the screen, I'll have to tweak up the one laser because it's really hard to see. There you go. Now we can zoom in and go over to the wall and see what the pattern looks like. The top slit spacing between those bright dots is about 4 times smaller than the spacing between the bright patches on the bottom. Okay, so telling us that the spacing between the dots is inversely proportional to the separation of the slits. So what I'm going to do now is I'm going to walk over, I'm going to turn out the lights, and my cameraman here is going to zoom in on the wall so that you can see the fainter part of the pattern, and I'll talk about that in a second. So let's first turn off the lights. And go back to here. Now I have to align that second laser properly so you can see the pattern. But let's talk about the bottom first. So you see there's an alternating pattern. The spots in the middle are quite bright. But then there are sort of spots that go off in all directions. Those are the different orders of the pattern. And the reason that it's modulated with a brightness to the left and the right that goes down and down and down is because of the diffraction in these two slits. So in this experiment, both diffraction and interference are actually operating. The interference creates the small spots of light, and the diffraction is that envelope that controls the brightness of the pattern as you go left to right. So now let me align that second laser so you can see the top pattern at the same time. So again, the bright in the middle and goes down, the brightness goes down as a function of distance away from the middle of the slit. So again, those top slits have about 1/4 the separation as the bottom slits, because x, the distance between the slits, is inversely proportional to the distance between the two slits that are interfering with each other. All right, that's it.